In this video, we are going to discuss the problem merge two sorted linked list. So here we are given with two linked lists consisting of n, m and nodes respectively. Our task is to merge both the list in place and return head of the merged list. So we have to merge these both lists. So the thing is that both these linked lists are already sorted. So we have to just merge them and the final list should also be sorted. This is our task. For example, the first list here contains 4 elements, which is 5, 10, 15, 40, which are sorted, and second list contains 2, 3, 20, which is also a sorted element. So one can easily merge this list accordingly, and the final list is this given to you. You have to return the head node of this particular list. This is what you have to do. Okay, so how can we do it? Let's check that how can we achieve this problem. How can we merge two sorted linked lists? Okay, so for example, these are the two sorted linked lists given to us, and let's take the same values which are given in our example case number 1. Okay, so we will also link the linked list with pointers, which is here, here, default. Okay, now I will assign them some values. So the values will be 5, 10, 15, 40 according to our example. Okay, and for second it is 2, 3 and 20. So the first is brute force approach. How can we do it with a brute force approach? So using brute force, it is a very simple. What we can do, we can take a third, we can generate a third linked list, for example here, and in that we can simply insert. First I will insert 2, then we will insert 3, then 5, then 10, then 15, 20 and 40. Like this we can do this. We can perform this operation. But this will require extra space. This will require on of extra space. This will not do that merging in O1, or you can say in place. In place is not there. But according to our program, we have to find a solution in which in place sorting is there. Means both the lists are merged in place and are sorted. This is what we have to do. Okay. So now let's think that how can we do this thing. We cannot perform this particular operation because in this operation you can see that the space complexity is on. There is a one more linked list form which is of size n and is basically the sum of size of both the linked lists. But we cannot perform this. We cannot do this. Now let's find that how can we obtain this solution? How can we perform and we can merge these lists in place. In place means only these, the given suitable nodes will be there only. We don't have to take any another node to store basically. We can take some temporary nodes. Obviously maybe somewhere we have to use some temporary nodes, but that is okay. Okay, but we cannot take extra on or like that of space complexity. Fine, we have to do the particular thing in O1 is. So how can we do that? Fine. So for that, what we will do, we will just change the position of the next pointer. So each node basically consists of a data and a pointer to the next node. This is the next node. This is basically next pointer which points toward the next node for that particular node. So currently in this list you can see that the smallest element we have is 3, is 2 basically. This is 2. 2 is in its place. After 2 is 3. So 2 is pointing towards 3. This is the correct thing. Now 3 is pointing towards 20, but this is not correct. 3 should point towards 5. So what we have to do is we have to make the next node of 3 to 5. Now after 5 to 10 it is right, then 10 to 15 it is okay. Then after 15 it should point towards 20 instead of 40, and 20 should point towards 40, and then 40 to null. This is what we want. This is what we want. This is a perfect linked list. If I erase these unwanted things here, okay, then you can see here that this is our required linked list. 2, then 3, then 5, 10, 15, 20, 10. We can simply return this particular node as a head pointer and we will get the whole list. This is what we can do. Okay, so now the thing is that how can we achieve this? How can we perform the operation? Okay, so what we will do is we will take some pointers. Okay, so we will take some iterators which will iterate through both the linked list. Okay, so let's take them. So we will take, so as it is given to us, we are given with a head pointer of first node. This is head 1 and this is head 2. So we will use that only, but we will also take a p pointer. Let's take a one more pointer p, or let's say one more node p. Okay, so this is this particular node, the first node of first linked list, and this is the first node of second list. There is a one more condition which we have to hold, which is that the value of head 1 should be less than the value of head. Value basically means the data. But here you can see that the head 1 is greater than head 2. It can be equal to also, but it cannot be greater than. So what we will do, we will swap them. So now these two are swapped. So now these two nodes are swapped. These whole nodes are swapped. Not only the values or data, these whole two nodes are swapped. So first of all, let me put pointers here. There it is. So we have to swap these both nodes. So now what we are doing here basically is, now this is our head 2 and this is our head 1. Now you can see that our head 1 is 2. Okay, this is the first condition which we have derived. Okay, now what we will do, we will go up to till the value of head 1 is less than the value of head 2. So we are currently at 2. Yeah, it's fine. Now we will go. Now let's write it more clearly. Okay, let's write it more clearly to avoid any confusion. I hope this is understandable to you, that head 1 should be less than head 2. This is our, and we will take a pointer p. So currently there are two pointers. Let's say this is h2, this is h1, and there's a p. So p will basically the trail pointer of h1. It will always be before h1. Okay, it will always be the at before h1, at before node h1. Okay, so now currently it is h2, it is h1. Okay, now so now what it will do is that this h1 will first compare with h2. So our condition was that h1 should be less than equal to h2. So for this particular, you can see that a condition is holding. h1 is less than h2. Now this h1 will iterate to the next node. It will become here, and this p will come here because it will always be before h1. Now we will check. So yeah, this h1 is less than h2 again. It is right. So now again, what I will do, I will update the values of h1 and p. I will update the value of h1. So now we have p here and h1 here. Now this is the thing. The value of h1 is greater than the value of h2. This is what we don't want. This is not the required condition. This is the condition. In this case, what I will do, I will swap the nodes. I will swap node H2 and node H1. Okay, I will swap the node H2 and node H1. So now this H1 will point towards, but before swapping, we have to also done a operation. But what is that operation? We have to think about that operation. Okay. So the first thing is that we are swapping these nodes. Okay. We are swapping these nodes. So now we have 20 was here, 5 was here. So now what we will do is, first of all, we will make the next pointer of this P node equal to H1. So currently this P is before H1. Okay. So the next pointer of P is towards H1. But now as we know that the value of H2 is less than H1, means the next pointer of P should towards H2. So now first condition what we will do, we will make the next pointer of P towards H2. This is what we will do. We will make the next pointer of this P towards H2. Okay, then we will swap. Now because this is smaller, now I will make this as H1 and this as H2. Then again I will iterate up to the condition hold. Again this H1 will go here and P will become here, because it will be always before H1. Then H1 will go here, P here, then H1 will go here and P here. Now again you can see H2 was 20, H1 is greater again. So again what we will do, we will make the next of this, means which was P currently, equal to H2, means 20. Okay, and then again I will swap the value. So you can see that the required linked list is here. It is if I erase this all the explanation part, just the arrows, then you can see that this is the only required linked list which we are talking about. You can see that here there is an arrow. Okay, there is an arrow, this one. So 3, from 3 it is going towards 5, then 10, 15, then again to 20. And then because here there was a H2 and there was a H1, which was here, this H1 was basically greater than. So again we have to swap. This is H1. So again we have to swap. So again after swapping, it will become, this will point towards here and then this will point toward null, because it is obviously null. It is a last, so it is obviously null. Don't have to make it null. It will always point towards the null. This is what we have to do. So okay, so let's code this, then you will understand it more clearly. Let's code this. Okay, so we will also code this in step by step. We will consider all the operations, all the steps which we have considered in our code. So the first step which I have talked was that first of all we have to basically check about that our H1 node should be at the lowest value, which is lowest. Okay, there are two corner cases also. The corner cases are that if the linked list 1 is empty, means null, that is also a case. In that case we have to just simply return linked list 2, and if list 2 is empty, means if it is empty, then I have to just return okay. This is what I have to do. Fine. So now the next thing what I have to do after this was was that the value of head 1 should be less than equal to the value of head. This was our first condition. Okay, so these are our sample cases, or you can say corner cases. Okay, these are our corner cases which we have considered. Then our next property was, our next condition was that the value of H1 should be less than H2. So if the value of H1, which is data, is greater than, it is not less than, If it is less than, then it's equal. But what if it is greater than? If it is greater than head 2 data, then as we have discussed, we will swap these two nodes. We will not swap the data, we will swap the whole nodes by taking a temp node or anything else. We will simply take temp node to swap these nodes. This will be right. Head 1 is equal to head 2. This is a simple swapping operation which you all should know. Okay, and this is how we swap both linked lists. Now what we will do? Now we know that the least element is at head 1. So that will be the start of our new merge list. That will be our start now. So obviously we will take a new node which is basically answer node, and that will be equal to head 1 because currently in head 1 we have our start node. The start node you can see here also. If I take, then you can see here that, just a minute, you can see here this was our thing, and correct at starting, when we are starting at the initial phase, this was our h1 and this was our h2 because h1 was less than h2, and this h1 was also our head node of our merge list. So we will initialize answer with h head 1, means our head node of merge list. So this is our answer. Okay, now the next thing what we have to do, now we will start our loops because we have to iterate through both the linked list. So we will take that while the value of head 1 is not equal to null and the value of head 2 is also not equal to null. Okay, this is what we have to check firstly. Then what we have to check, then we have to take a tail pointer, a p pointer, which will be always behind head 1. As I told you, it will be always behind head 1. We will take it as p as we have discussed, and initially it will become null. Okay, then I have told you that while the value of head 1 is not equal to null and the value of head 1 is less than equal to the value at head 2. While this condition is hold, I have told you now, the condition is that the value of at head 1 should be less than equal to a value of head 2. Until this condition will hold, we have to iterate. And how we have to iterate? We have to make our head 1 equal to head 1. But we have to also do one thing, because we have to make the p as a just before node of head 1. So we will initialize the update the value of p, and then we will update the value of head. Okay, now this loop will break if the value of head 1 will become greater, or in case the head 1 will become null. So if head 1 will become null, then we don't have to do anything, it will terminate. But if this will become greater, then we have to perform the same operation which we have done here. We have to perform swapping, the same thing which we have done here. Okay, so we have to perform swap. This is what we have to do. But before swapping, we have to also perform one more operation which we have discussed. What was that operation? The operation was that we have to make the next pointer of this p node to h2 and head 2. This is what I have discussed. That is why this is the reason we are taking p node. Okay, this is what we have to do. So now here we have to update the value of p. So now p next is equal to head 2. Okay, this is what we have to do. Fine. Yeah, So let us understand this once more, all the operation which we have done currently. Okay, so what we have done, first of all, we have checked the corner cases. Then we have checked, we have made the value of the node head 1 should always contain the data less than a node head 2, and if it is not, we have swapped it. Okay, then we have started, we have to iterate through both the linked list. Then again we have checked for the same condition, the data head 1 should be less than equal to. If it is not, then we have to break this loop and we have to swap the values. Before swapping, we have to make the next of p is equal to head 2, because here is where we are doing merging. We are connecting the both the linked list. This is the exact where we are merging the list, and then after this while loop we have to just return our answer ns, okay, which we have. Fine, this is what we have to do. This is what we have discussed in our program also. You can see here we have discussed here that what we have to do. The same program, the same technique we have discussed in our code also. Fine, yeah. So let us understand this thing one more, that we have just first taken two pointers, h1 means head 1 and head 2. Then what we have done, then we have simply checked for the condition that the head 1 should be, this head 1 should be less than equal to head 2. This is what we have checked. After doing this thing, what we have done, that this condition should hold for all the cases. Fine, this is what we have checked, we have done. And until this condition will hold, we will iterate, and when this condition will become null, means the value of head 1 will become greater than the value of head 2, then we will break the array and we will swap the nodes. Fine, this is what we have to do. So now let's submit the code which we have written. Okay, let's submit this code. First let's compile it. You can see that this is compiled successfully. Let's submit it. So all the test cases are passed. So if we talk about the time complexity and space complexity of this solution, so you can see here that the time complexity is on, and this n is basically this n plus m, means both the nodes. Okay, this is the time complexity of this particular solution. And if we talk about the, this n is basically the length of first linked list, m is length of second linked list. So this is basically equal to small n. And the space complexity is O1 only, because we are not taking any extra space. We are not taking any. So this is space complexity and time complexity for this solution.